Today we're going to be talking about box plots and histograms. Um, so the data set that we're considering today is on the Titanic. The Titanic has all of these variables, whether or not the individual survived or not, and we also have their age. Okay, so right here. There are a lot of other variables such as the sex, the passenger class, um, where they embarked. Um, then they coded survival as another variable as alive here, so you could use this variable alive, or you could use survived coded as 0, 1. Okay. Um, Here we make a plot of the box plot of the age uh, by whether or not they survived or not. The 0 is no, they did not survive. The 1 is yes, they did survive. And we produce this box plot. Um, a box plot is appropriate when you have a numeric input, such as age, and a categorical response, such as survived or not. There can be more than one uh, category for the response, um, or even just no category for the response. A common thing to do with a box plot um, is to compare two populations. In this case, we'd be asking the question, is there a difference um, of survival based on age? So first, let me tell you a little bit about box plots. So box plots show probabilities. In particular, they show percentiles. Um, so a percentile um, is defined by P sub k, and that's here. And the percentiles that are shown in the box plot are the 25th, the 50th, and the 75th percentile. Okay. Um, so the 25th percentile, that's called the first quartile. That means that 25% of this 25% of the data is below this value. And here, if you trace it back, it looks like it's just below 20. And in fact, we calculate exactly what that value is. Okay, it happens to be 19. That's the 25th percentile. Okay, um, so 25% of the people who survived were less than 19 years old. Okay, that's one percentile. Another percentile is this middle bar. That's called the median. Okay. The median means 50% of the individuals have a value of less than that value, and that value is 28, and 50% are older than 28. Okay. Now, the next percentage is called the third quartile, and percentage. And that means that 75% of the individuals have this value or less, and I'll need to check what that value is. It's 36. So 36 is the third quartile, meaning that 75% of the individuals are less than 36 years of age. Okay. Um, that also means that 25% of individuals were older than 36. Another fact from these percentages or quartiles is that 50% of the data is in the box, meaning that 50% of the people who survived have an age between 19 and 36 years of age. Now, This right here, that's called the upper fence. That has a value of around 60. The upper fence is calculated by the third quartile plus 1.5 times the interquartile range. The interquartile range is just the third quartile minus the first quartile. So 36 minus 19 would be the value. Okay. The other fence, the lower fence, is the first quartile minus 1.5 times the interquartile range. And any observation above this upper fence is considered an outlier. Any observation below this lower fence is considered a potential outlier. Okay. One key takeaway in looking at this box plot is that the two box plots look about the same. So it doesn't seem as if age affects your chances of survival. Um, one other thing is that a box plot is considered symmetrical, and this is mostly symmetrical because the median is right in the middle of the box between the first and the third quartile. The other aspect that makes this approximately symmetrical is that if you look at what's above the median, it looks about like what's below it. That is, if you folded the upper half down, it looks pretty similar. Okay. The same for the individuals who did not survive, though it looks slightly more skewed because the median doesn't appear to be exactly in the middle. And one thing to note is that it's not perfectly symmetrical because there are no outliers here in the bottom part. Okay. So a couple of things, conclusions, and we'll just go through the survived population. But some key takeaways is that 50% of the data, 50% of the people who survived are between 19 and 26. The median is 28. My apologies there. And the elderly are much less likely to survive. But if we look at the died group, it doesn't look like that demographic's much different. It just looks like there aren't that many elderly on the Titanic. And that it seems like more younger people are on the Titanic because we don't see too much of it here. Okay. Um, and and one last key takeaway is that there aren't the graph seems to be approximately symmetrical. Okay. Um, One purpose in comparing it, as I mentioned before, is uh, to compare the two populations, the survived versus the died. And we see that there doesn't appear to be too much of a difference. Okay. So very similar statistics are reported here versus here, whether they're the died or the survived group. Okay. We can see that there isn't very much difference as well with a histogram. Okay. So the blue represents the died. The uh, the yellowish here, the one group represents the survived, and we see a very similar shape to the histogram. And that tells us, because they're basically overlaid and have very similar shapes, that there doesn't appear to be a difference in who survives versus who died based on age. Okay. Now this graph is called a histogram, and it has a stepwise shape, right? It goes up, it goes over, it goes up, it goes over, it goes down, it goes over, etc. Okay, so that's what I mean by stepwise. The stepwise shape for each interval in that step, that represents either the counts or the probability to that outcome corresponding to the x-axis. So for example, the most common age that survived is between 20 and 30 here for the survived group, and that's the most common age. Okay, we see that that's the same for the died group. That's the most common group that died, is also between 20 and 30. Okay. The histogram reveals that it is slightly skewed with some larger observations here. Um, the histogram can display probabilities for the segments. So all you have to do to get probability is take the counts and divide by the total number in the observation group. Okay, so for 20 to 30-year-olds who died, it's about 20%. Okay, then just thinking about these two graphs in terms of the design of experiment, um, let's just remind ourselves that a data set is a design experiment if we can assign people to inputs or treatments. The data is observational if we're just observing the outcomes. Okay. In this case, it's not possible to assign people to age groups. It's just not possible. So the only type of data this can be is observational. Okay. So our conclusions from this data are restricted to associations. In terms of test of hypotheses, researchers are wondering if the survival is different based on age for passengers of the Titanic. The null is a statement of no effect, that age does not affect the probability of survival. It's always a statement of no effect or equality. The alternative is that the probability of survival is not the same based on age. Okay. So in terms of these two graphs, because this one is overlaid and because these two are side by side with very similar values, this suggests that age does not play a role in survival.